Okay, first up, are we ready?
Okay, give us 2 more minutes.
Ah,
Go my colleague downstairs.
No, it's not a good programming session. Unless you have a great program idea if you want to implement it as microservices today.
I guess we can start.
Oh, we can start? Yeah. Okay. So I'm going to do this sometime in between. Okay. So my name is Lutz. I work for Lagom, and the next 25 minutes or hour or so, I will talk about Lagom. And what is so I want to talk about, well, Lagom is a service, it's a framework to build microservices, right? And there are a couple of so-called micro frameworks out there, and Lagom is special. It has some, I think it has some attributes, it has some characteristics that others don't have. It's interesting in certain ways. So I'm not going to show you how to build a hello world REST service with Lagom, because we did this in a lot of presentations and everybody said, oh yeah, well I could have done this. I could have done this with Spring Boot the same way, or with whatever framework, because it's easy to build a hello world service with any of the frameworks out there. I want to emphasize the things that differentiate Lagom from the other frameworks out there. So I want to talk about the things that are special in Lagom. Oh wait, this is not working because it has a second bit that I have to. As always in IT, there's no magic. You can connect the dots. So why do we build microservices anyway? Or are you building microservices in your company? No. Maybe nobody is. Oh, okay, some people are, or they're looking into it. It's a bit unclear how many people actually do it in reality. I think there's a slight difference between the amount of hype around it and the talking around it and the people actually doing it. But we think it's not just hype. We think there's a lot of common sense to it. So, well, on one hand is one thing is that these old architectures, having a big application server and putting your WAR and EAR files in it, we think it's obsolete, and these guys from Gartner think they're true. And I saw a presentation in 2013, I think, from somebody called Eberhard Wolf, another German guy, saying the application server is dead. Where he made a very nice argument why it's really pointless to use the Java EE application service at this point in time, because it doesn't give you the amount of isolation you want. You don't want a server with a number of applications on it. You want an application that runs on a number of servers. And you don't want one container with a couple of walls in it. And most people don't do it. Most people just want one application per Tomcat, for example. So they can start them independently, and if one crashes, it doesn't affect the others. So, but if you only deploy one application on your application server just becomes a dependency of your application. It's just another couple of jobs that you have in your dependency tree. You just have a dependency that deals with the HTTP protocol, with the sort of listening to a TCP port and handling the incoming requests. So, and if you get into this thinking, it makes much more sense to build your applications in a different way as well. But okay, this is just a technical detail. Why microservices? Well, we've always wanted to isolate things. Right? We always wanted to have loose coupling between software components. We always wanted to be able to modify one thing without having to modify the other, to have clear interfaces between these. And object orientation is a big deal about that. Other module, even before object orientation or besides object orientation, we had module systems and the idea of modularity and isolation of parts. And now we want to take this all the way to operations. Right? We don't only want to build, sort of write our software in independent modules, but then have this big lockstep release where we put everything together, then we have to make this big deployment and change everything with all these things then getting intermingled, and you're not quite sure if this change may still affect some other part of the system, things like that. We want to be able to take one part of our application and modify it all the way to deployment, right? We want to be able to change one service and even deploy this independently of others. And maybe scale it independently of others. It surely should be able to crash independently of others, right? If one service crashes, it should not affect others. So all these things make a lot of sense. And if you sort of look beyond the hype of microservices, you see that there's a lot of good behind that. But of course, we have to, this is of course what it is. I keep talking without looking at the slides I had. So, of course, this is what it's about. Single application as a suite of small services. This is also something that's very interesting. It's never about one microservice, right? You don't want to, if you build one microservice, if you build one service, well, it can still be an application, but it's not really about microservices. The interesting part is where you have a couple of services or a big number of services. This is also something where Lagom has something to contribute. Now, we want to do this, we want to build these things independently, we want to build them as resilient services, but then we realize, okay, there's a couple of things that become more difficult now. We wanted to make life easier, we wanted to get away from difficulties we had in monolithic development, but now we have other problems, as usual in life, right? If you try to solve one problem, other problems show up. So if you're working with microservices, you're going to build a distributed system, you have to deal with that somehow. Services have to find each other. Services have to communicate also. If you build microservices, you have, each service should be responsible for its own data, right? Otherwise, it's just a monolith hidden under a couple of services if they just share a central database. So your data is going to be distributed among different microservices. And you most likely have operations that affect a couple of services, but you will not have strong consistency. You will not have sort of traditional asset style consistency across services. So you're going to have to deal with eventual consistency. And well, now rather than having one application you have to deploy, one big application server you have to deploy, you have tens, bigger companies have hundreds of services you have to deploy on a huge number of nodes possibly. So the operational complexity also increases. And these are, this is actually not something that we created. This is not our marketing, not from Oliver. This is actually something Martin Fowler wrote, who's famous for for a lot of things, for the books he wrote, Enterprise Application Integration Pattern, something, I forgot the title. I think it's just called Enterprise Application Integration. And, it's called Enterprise Integration Patterns. And Refactoring is another book he's written. And he has this wiki blog kind of thing that he calls Wiki, where he sort of keeps updated postings about current trends. Well, at this point, current trends in software development, and of course they stay there even beyond being current. So current and past trends in software development. And so logically he's also written about microservices. I think the definition on this slide before this was also by him. And he said, okay, these are the main trade-offs he sees, or the main complexities he sees. Distributed systems are harder to program because remote ones are slow. There's always a risk of failure. That's right, you have to deal with failure. Things fail in distributed systems. There's going to be nodes crashing. There's going to be networks not working. Everybody has experienced this, and you won't be able to manage or to maintain strong consistency. These are the two sort of development concerns or software architecture concerns. And then the third one, of course, the operational side, where we're going to get back to at the end. But this is not so much about Lagom. This is more around how you operate your services later. But Lagom is more about the first two. So enter Lagom. Why? We already, if you know Lightband, you know we do Scala, Akka, Play. So we already have two fine, actually, you can use Play to build a microservice or to build a REST service. You can use Akka HTTP, to build a REST service. Okay, I'm going to take some water. So we already have two frameworks to build microservices. Why would we have a third one? And why would we press that button? Well, it's about levels of abstraction, really. Software development is about which abstractions we choose. We build models, right? We have something in reality that we want to model in our software. So we need some kind of abstraction. And we found that, well, obviously there are different layers. For example, Actor gives you the actor model, which is a great model for concurrency, location transparency, for building highly concurrent applications, also for resilience with the supervision model. Everything is an actor has an address, you send messages to actors, actors are limited in what they can do. It's a great model, and everything we can do, we can build with this. But it's a bit low level, right? So this just the actor model, if you look at Akka, just Akka already gives you another level of abstractions. It gives you Akka cluster, for example. So it handles cluster membership and nodes joining and leaving the cluster. It includes Akka persistence, cluster sharding, things like this, higher levels of abstractions. Of course, you could do this all with the Akka model alone, and in fact it does it just that way. But it's kind of low level. That would be a lot of work to do this. Now, in the same spirit, you could build stream processing with actors. But if you want to do this in a sort of, if you want to have high-level transformations, and also maybe you might want to deal with back pressure and being able to detect when the downstream sources or the downstream stages are not able to process more data, things like this. To program this with Akka, with the Akka model alone, with actors alone, again, is a lot of work. So we provided reactive streams, or an implementation of reactive streams, named Akka streams, to give you this level of abstraction. And this is also where Lagom comes in, right? We say, okay, what abstractions do you need to be productive in microservice development? So it's not really an alternative to Akka or an alternative to Play. Actually, these are both dependencies of Lagom. Lagom both uses Akka and Play. It's just it's like a level on top of it. We say, okay, to make you more productive as a developer, to give you some abstractions that are hopefully the ones that make it easier for you to develop microservices, we created this Lagom abstraction. So this is where it fits in our software stack. Of course, there's still a place for Play or for Akka. I think this text has actually changed on the website. So this is a snapshot from the screen here, a snapshot from the website. It used to be the Lagom framework homepage. And one thing you're not going to notice here is we say it's highly opinionated. Now this is interesting, right? We say this framework is highly opinionated. We have certain opinions how we want you to build your software. So what are these opinions? And this is what I'm going to, I think this is stretched a lot. So it's very much, as a lot of microservice development, it's influenced by domain-driven design. Although it's technically, you really don't see it in terms of the classes and interfaces we provide. But it's clearly our idea of the size of the service, and I'm going to talk about this a bit in the next couple of slides. Then we tend very heavily towards event sourcing and CQRS. If you're not familiar with these concepts, I'm going to explain them, at least sort of in the context of Lagom, how we implemented it. And then, of course, we're the reactive company, right? We're all about being resilient and elastic and building your services that way. And of course, microservices too have to be this. And I'm going to quickly show, or going to quickly tell you how we treat this in Lagom. And then, as this whole thing is about developer productivity, of course, it's also important that we give you a developer experience that's nice. And then I'm going to show you that as well. And that's where the command lines are coming. Okay, so why is it called Lagom? Well, the term microservices is a bit unfortunate because it indicates that it's really about the number of lines of code made with your service. We think that's not a good metric. It's not about how many lines of code your service has. Plus, that will be very dependent on the programming language you use. Although very smart people say it would be about that. I think just recently somebody told me, oh, there is this 400 lines thing, which is kind of a magic number, and people have done studies, and a program with 400 lines of code you can easily sort of have a mental model of. And if it becomes more than that, then it becomes more, I don't know. I don't believe in this lines of code metrics, and luckily a lot of other people also don't. So don't focus on the micro aspect too much. Don't think about lines of code. What should you think about? What's it called? The Unix principle. So the idea behind the Unix command line tools was not to create complex tools, at least until they started programming Emacs, but the real command line tools, like you can output the text and then you use org to sort of filter it or set to replace things, and you pipe it into something else and so on. So each tool does one thing, just one thing, and just do one thing, do that well, and play nicely with others. So it's about single responsibility. It's about only having sort of one thing that is controlled. So after hours, InnoQ, they're called, a consultancy, they created this paper calling them self-contained systems, not self-contained services, self-contained systems, to express this very same idea. It's about single responsibility, it's not about lines of code. So when it comes to the size, it's not about being micro, it's about being the right size, as somebody wrote in another blog. Hello, right-size services. The right-size services does not, how am I going to say, it doesn't roll off the tongue easily. So we have a lot of Swedish guys in the company. And one of the guys says, no, right-size services, I can't even say this properly, I'm going to call them Lagom services because that's a Swedish word. And now we get to the actual meaning of it. Lagom means just the right size or just the right amount. For example, if you invite people over for food, and you eat, and at the end of the meal, all the food is gone, but nobody is hungry, everybody's full. And there's no leftovers, but nobody stays hungry. It was just exactly the right amount of food. So that will be the Lagom, or whatever the Swedish say for the right amount of food. And you can use this for a great many things. So the temperature can be just right. If it's it's nice outside, it's not too hot, you don't get sweaty, but you can just wear a t-shirt, you don't have to wear a jacket, it's just Lagom. Well, what have you. So, okay, so we wanted to be just the right size, and this is where we loop back to the domain-driven design ideas. Right? This is from Sam Newman. You've probably seen the book, Implementing Microservices, and he mentioned this as well. We feel the same way. We think, thinking in these domain-driven design terms, and this plays very well with the single responsibility, right? It's looking at a bounded context, where you have, so basically, where things have one meaning and sort of don't interfere with others, right? So where you have a clear boundary towards the other subdomains in the system. We think this is the right size for a microservice. So this is good because if you want to build microservices, you can just get for architecting your system, you can just get a DVD book or a DVD consultant and sort of take this domain-driven design approach and you're going to end up with a nice service-based system. And I'm not going to talk about DDD much more, but in Lagom persistence, you're going to notice that, well, if that we think a service corresponds to a bounded context in DDD, and then what we're going to look at is how we persist things, and that's going to correspond to aggregate groups. So Lagom persistence is one of the modules in Lagom. It has Lagom has a couple of components, the main ones being the service API, and another one being the persistence API, or the Lagom persistence module. And I think this is quite different from, this is very close to Akka persistence. If you use Akka persistence, it's going to be instantly familiar. If you've used quad sort of relational databases and Hibernate or things like that, it's going to be very, very different. So we want to push people towards using event sourcing in CQRS. Maybe not for everything, but we think it's a good default and people could use that more. But we will try to make it simple too, so we put a lot of structure around this. But this is part of the being opinionated, right? And also, for example, we give you Cassandra as a data store. I'm going to show it to you when I show the development environment. We just fire up Cassandra for you, and then you don't have to configure anything basically for development. We'll just use Cassandra. So, how does it sort of? Okay, now I'm going to talk about event sourcing CQRS a bit. So, CQRS, in case you're not familiar with that, it's command query responsibility segregation. Basically, it means separate the write side and the read side. Make them two completely different things. And then you can, as different things go, you can still do that in the same way. You can use the same database. Actually, for default, in Lagom, you would use Cassandra for both. But you don't have to. You can use very, very separate things. And they're sort of, they're considered two separate parts of the application, the write side and the read side. Event sourcing leads to CQRS. If you do event sourcing, the idea, well, I'm going to talk about this on the next couple of slides. Just for the logic. You could do CQRS without event sourcing, but you cannot do event sourcing without CQRS. If you do event sourcing, this will make you use CQRS. And Lagom persistence makes you use event sourcing, so in turn, transitively makes you use CQRS. So, one step back. So in this whole DDD world, there's the idea of an aggregate root, which we call persistent entity, or which corresponds to a persistent entity in Lagom. In Lagom, so the superclass is persistent entity. Now, entity might be a bit misleading in this context. If you think of relational databases, and then, for example, Hibernate or JPA, you usually think of an entity as a sort of row in a database table. Here, this entity can actually contain relationships as well. It can be, in our example, it's a user and his friends or followers. It's basically what you consider an interesting entity in your application, also where you aggregate the basic sort of your I forgot the term I was looking for. Well, anyway. Maybe important to note is that this is also the boundary of your operations, your transactional boundary. If you can operate on one entity, and that's fine, then you have strong consistency. If you go beyond that, you won't. Now, how do you work with persistent entities? You don't just set something. You don't just change a field of it. You send it a command. For example, in our example with the friend service, you say add this friend. We have in our friend service, we have Peter, Alice, and Bob. So you're going to get this command. And this command may have some side effects, or maybe a command can be anything really. It can be an invalid command. You could discard it. It could trigger some side effects. But if it's really the add friend command, for example, this will trigger a state change in this. Right? It will add a friend to this entity. So the way we do this is we issue an event. We say, okay, this leads to a friend-added event, and this will change the state of our entity. Rather than just setting a field and say, to this list of friends, append a friend, we send it an add friend command, this will issue a friend edit event and then actually add the friend to the list. So then we store this event, right? I'm going to come back to this later. A basic idea of this is, or what one of the prerequisites to do this in the way I'm describing, is that you can spread out your Lagom application among multiple nodes. So each Lagom service, each single service, each of these microservices is an application you can spread out in the cluster. Each of these services is based on Akka cluster, so you can add more nodes and remove them dynamically at one time. This is sort of people sometimes don't realize that we're talking about a single service here, that each single service can be, and this is what you need, right? Each of your services must be able to scale. So you need to be able to spread out your services across the cluster. So our persistent entities can also be using cluster sharding, we can distribute them in the cluster. So we have a cluster in this example of 3 nodes. Not all the entities have to be on one node. Akka is going to take care of this, or Lagom is going to take care of distributing our entities in the cluster. So this allows us to keep all the entities in memory. This is not necessarily, so there might be other event sourcing approaches that are different, but the Akka persistence, or the Lagom approach to event sourcing is, you have your persistent entity and basically it's in memory all the time. You create this entity, it's in memory. Which is nice because it's fast. You send it the commands, and then also you say, I want to send this command to a certain entity. Some sharding coordinator is going to know where this entity lives, and your cluster is going to send the command. So this scales very nicely, it's very fast because it's all in memory. But this is an old idea. Again, my friend Martin Fowler, he calls this a memory image approach. Obviously, because you have an image of all your data in memory. What's the problem if you have all the data in memory? I said this earlier about just what happens in systems, and especially also in distributed systems. Things fail, things crash. If your entity is just in memory, on node B, and node B explodes, where's your data? So this is where the actual event sourcing part of the event sourcing comes in. All the state changes I talked about, right, they are all persistent, they are all logged. So we get the command and we get this, the add friend command, we get this friend added event, and we persist this event. And now, the state of our actor, the list of friends of our persistent entity, the list of friends in there, is just a snapshot of our event, also the snapshot of the current state of the system. But the real truth is in the persistent log, in the persistent events. If an actor crashes, if a node crashes, and we have these events persisted, we can create this persistent entity again on some other node, and we just replay the events, and we're going to end up in the same state. So the current state. So we create the user Alice in this case, we add Bob, we add Peter. Oh, now we realize, no, this is the wrong Bob, we remove Bob. This would be a typical or a simple sequence of events that happen. And we just persist this in a relational database. Rather than persisting the events, we would change the state in place. We would say delete Bob, and then Bob would be gone. Which, if we don't keep an audit log, actually loses we actually lose information there. Right? We cannot recreate the sequence of events from just looking at this. We don't know that Bob was actually added before and then removed. Which is maybe not so important in this case, but it's interesting in the event sourcing case that we have this information. So a couple of reasons why we want to push you towards event sourcing is it's really just about, so you don't have to think about object relational, sort of mapping your object graph or your actor relationships into a relational database, which can be a pain in object relational mappers. You automatically get an audit log. Basically, that's all you have. You need to start with. You just save all the events, and you never lose any information. You never delete. Now, what's I said in the traditional way, we might lose information. If we don't keep an audit log, we delete something, this information is gone. We cannot see how we came to this state. If we consider the state as the consequence of the event log, we can always replay this. And we can also, if we want to have a different view on things, we can create this as well. Basically, our in-memory model becomes just one projection of the event log. And we could say, okay, we want to look at things in a different way, and just recreate and replay the events with other effects. So when we keep all the event log, we can use this to support ways of looking at the data that we haven't even thought of when we created our system. It scales very nicely because it's append only, right? You just append to your log. It can be, and this is actually something we could support even better in Lagom right now. I don't think there's an easy way to do this, but one thing you can do in this model is just keep track of all the commands you get and all the events issued, and then replay this, and then you can detect changes in your system like this, for example. It's easy to do regressions if you see, oh, this sequence of commands now led to different events. So it can lead to very good testability too. What does it look like in Lagom? Let's look at some source code. So all the things with the event sourcing, you could already do this in Akka persistence, but now it's really, as I said on an earlier slide, it's like persistent on Rails. We really want to guide value towards a certain approach. And one of this is sort of using types to express, or sort of to give more clarity to what you can do or what the things are you operate with. Right? So you parameterize, and this is, I'm sorry, this is all Java code. Actually, I might have a Scala example too. Oh, it's a more complex example. Let's look at the Java code first, because this is like the simplest, it's called Hello World, so you probably guess this is like the simplest entity you could build. All it does is, well, it has to persist something, so you can send it a, what does it do? The REST service that we built here, you can send it a name, and it will say good morning, and repeat the name or something. And then you can also, that also has a post command where you can say, okay, for this name, use a different command, and restore the command for this name, so the greeting for this name, the next time you request a greeting from this guy, it's going to use a different command. So, this is the type for the commands, and this is, if you're all Scala developers, right? This is a Scala user group. So in Scala, you would use an algebraic data type for this, or you want to just use a sealed trait hello command with a couple of case objects or case classes as the commands. In Java, it's a bit more involved. It's an interface with final classes and a lot of code, and some annotations, and you could actually you could probably use a different annotation library to generate the immutable value objects you want to have. But really think of this as sort of standard Scala ADTs for the commands. So you have one type for the command, where's my entity? One for the events, and one for the state. It's also, just for more clarity, rather than having some fields in the object, we say, okay, here, one state, so we can make all of these immutable. Your world state is also going to be an immutable value object, and after an event is processed, you're going to get a new version of the state with a new field state. And of course, yeah, the state is also, we're going to talk about snapshots later, but of course you could also serialize the current state of your entity, and that will be, in this case, this world state class. So you have to handle commands. So you have to register a command handler, and this is, if you've used Akka for Java, I hope you didn't have to, but but it looks similar to the receive builder stuff in Akka Java. So you provide the message you react to. In this case, this command here, and then you forgot what this is, but then you provide a lambda, with a lambda, and it tells you what to do, and this is then persistent. It actually will generate an event here, right? This is decoupled. A command could actually, well, you see here that the event handler and command handler are different beasts, which seems a bit tedious maybe if you just want to implement a simple thing like changing the greeting here. But principally these are separate, right? One command could be a query and not leading to an event at all, not leading to a state change at all. It could be a command that just queries the current state, or that has some side effect but doesn't affect the state, so you wouldn't have to issue an event. Or a command could lead to a couple of events, maybe. So, or you could have a number of commands that would all lead to the same event. So it does make sense to separate events and commands, and also command handlers and event handlers. So, yeah. See, for read-only commands, there's even a separate command handler. And yeah, this will show you a new version of the state, and it will set an entity to it. So you see it's a bit, it does give you guidelines, right? You see it looks a bit boilerplatey, but also it's a very clear structure that we have to follow. Or in the Scala API will be an even clearer structure. So will look hopefully a bit less boilerplatey, but you have the same clarity. So we already looked at the classes. Let's look at the Scala example quickly again. Actually, I must admit I haven't looked at this in a while. So here, this is the chirper example, or we call this chirper. It's like Twitter. You have people following each other and they can chirp. So these are the events here. You see this is, if you do some Scala, this is a very typical structure. You have this sealed trade and then a couple of case classes. Extending this sealed trade so you have this, so you have a little sum type in here. And here, well, yeah, the thing about this Scala example is that it actually uses the Java API of Lagom, because we don't really have a Scala API yet. So it doesn't really look different from the Java example in terms of setting the handlers and stuff like this. Okay, so this is basically the persistent entity and the commands and events. Let's look a bit further sort of into this whole event sourcing thing. So we have this persistent entity and all the events are stored in a data store, in our case Cassandra. There are a couple of optimizations you can apply. So people ask, oh, if you store every event and now you recreate the persistent entity on another node, isn't that very inefficient? Maybe it was 1 million events that led to the current state. Now you have to replay all the events. Well, you don't necessarily have to. You can create snapshots as well. And say, okay, at this point, I'm just going to, just as an optimization, after 1,000 events, or in this example 100, I'm just going to persist the current state of my entity. And then if I want to recreate it, I don't have to start from 0. I just start at the last snapshot and replay the events from there. Makes sense, right? But keep in mind that this is not the nature of event sourcing. This is an optimization. You should not throw the events away, because, as I said earlier, maybe you want future projections that you haven't even thought of. So you want to keep all that information. And you can. So this is a little digression here, but why haven't we done this forever? Because hardware was very expensive. I say, oh, you can just keep all the application state in memory. We can do this now, where you can get an Amazon X instance with 2 terabytes. Well, probably you're not going to use 2 terabytes per node in your application, but having sort of a couple of gigabytes on a node is cheap today. It wasn't 15 years ago or so. Well, event sourcing, I think the whole DDD event sourcing, CQRS stuff became sort of mainstreamy or sort of became a lot of attention maybe 10 years ago or so. And this was, well, luckily this was the point, at this point, hardware was already cheap enough to play with this. I think now it's really cheap enough to use this seriously. And storing the events, we say, okay, if I store forever, I'm going to run out of disk space eventually. Well, maybe not, because there's a nice little mind game or sort of thought experiment by Greg Young about this. So that if you look at how much cheaper storage gets over time, like how much disk space you get for $500, and so the development of the disk space, sort of Moore's law-like, sort of how fast the disk space growth that you get for $500 is probably faster than the growth of data in the application. And he actually calculated something that said how much data you would have to store per day to actually beat this curve. So at the point, so if you buy a terabyte drive now, at the point where your application fills this terabyte, the next generation of drives is going to be available, and you can just keep writing and never have to delete anything. So, but back to this. So there's the one activation snapshots. There's another optimization, and this is passivation. I said keep all your data in memory. You don't have to though. But it might make sense. Well, it might be a bit over the top, right? If it's it's a user. In this case, in our Czech application, it's a user, and you really only need the user. You only interact with the user if the user is logged on into the system. Now you might log in and use it for a couple of hours and then not use it for a week. And this is also something Lagom does. It will call it passivate. It will passivate this instance, basically evict it from memory, and if another command is sent to this persistent entity, it's going to be automatically recreated, reactivated. So again, that's not the nature of things, but it's an optimization, which allows you basically to live with less memory. So keep all data memory is the basic idea. Optimization, only the working set. Store all stations as events. Replay all events in of a persistent entity if you have to recreate it. Or again, an optimization start from a snapshot, and you can scale it out in a cluster. And of course, well, if you want to scale it out, your data store also has to be scalable. The data store, of course, can become the bottleneck. With Cassandra, I think we're pretty safe there because it scales quite nicely. So this is the essence of the long persistence. This is all about event storing. Now I want to read. I said it's also command query responsibility segregation. So this was all the write side. We can get all these events stored in Cassandra and we can recreate actors. What about the read side? So we create, what's the problem with the read side? Maybe let's look at it this way. If I have an entity, I can query this entity. If I know Alice, I can ask Alice, who are your friends? But if I don't want to query the same entity, maybe I want to ask Bob. So let's say they're not friends, they're followers. Let's say I can ask Alice. I know Alice. I would point her to Alice or whatever. I know her. I have the ID. I say, Alice, who are your followers? And she can give me a list of followers. No problem. Now I want to ask who is being followed by Bob. Now I could ask every persistent entity, are you followed by Bob? But that's obviously a bit inefficient. So what you do is you create the read side in the way you want to query it. So in this case, we would create another projection. I think this is what we want to know. Bob's following people. So we just create the we create a read side. We create a table on the read side that gives us the projection we're interested in. So we just use the person that is following as the key, and the person that is being followed as the value in this case. It's a simple table with really an ID, and of course we have a couple of columns there. Here we're just interested in the person that's being followed. I think that's a weird name. It should not be followed by. Forget about the name. But this is, if you work with Cassandra, if you work with these kind of data stores, you don't use secondary indices as you work in relational databases, right? They're very, they don't work that way. You cannot just say, okay, I create an index on the on this other follower column, so I can query that. You really have to think about the things you want to query at the point you define your schema. When you define your schema, you really create a denormalized data model to support the queries you're interested in. We support Cassandra also for the read side. You actually get a read side processor with Lagom persistence to update your read side of Cassandra. This is also event driven, right? The event that leads to a state change in your persistent entity is also passed on to the read side processor. So it's the read side processor creates the view based on these events it gets. And Lagom does some supports you a bit around this. It will also it will give a sequence ID to the events and will take care of events that are being out of order. These are all things you have to handle in a system like this, because it's all event-based and it could be distributed. But events could get lost at some point. You update. What was it? We said add Bob, remove Bob. So maybe the add Bob event gets lost, and the remove Bob event gets in, but there's no Bob to remove on our read side, and so we don't do anything, and then the add Bob event comes in, right? So this can happen, of course, in a distributed system, that events arrive out of order because maybe there was a little network problem in the moment that was sent for the first time, and things like that. So the Lagom read processor will actually buffer them for a while and take care that events are not written out of order. The nice thing about this segregation between read and write side is that you can use separate technologies for the read and write side, and we're going to support more with Lagom as well. As the next one, we're going to support SQL databases, basically JPA probably, is it JPA or some JDBC, let's say. So you can use SQL if you want for both, but especially for the read side, which allows you to use all the tooling you have around your SQL databases for the read side, for example. Reporting tools, or what have you. Of course, you could also use something like Elasticsearch or some whatever you're interested in on the read side. If quick searchability is your thing, you could use that. Or you could stream the events to an analytics tool as well. This is I'm about done with Lagom persistence. So the read side could be discarded, and it's just a copy. It's just a projection. It's also write once, right? And you sort of the event comes in, the read side is updated, but all the readers, the consumers of the read side, are never going to modify it. So it's easy to scale out as well. You can just replicate it among a couple of nodes. And also, this touches the whole consistency thing. Don't become so overexcited about this. It doesn't mean that you can never query the state of the entity, that you always have to go to the read side. If I know Alice, I want to ask Alice, what are your followers? I can just ask Alice. I don't have to go to the read side. And this is also important. Well, let's quickly look at consistency in this whole thing, because it was one of the other things that Martin Fowler mentioned as well, like eventual consistency. So we have different areas where we can look at consistency. Our persistent entity itself, is it distributed in the cluster? Can there be different versions of it? Can it be inconsistent? Then we have some kind of journal where we store the events, the data store, which is distributed as well. And then we have the read side, which is updated by events, as I said. So Lagom does not keep copies of the persistent entities. If in the persistent entity the server crashes with the memory entity, it has to be recreated from the store. In the Lagom cluster, there's always only going to be one Alice. Well, in our case, where Alice is the ID of this entity. Right? So there's strong consistency there. You don't have to make sure that Alice is consistent with another copy of Alice. Right? So it actually values consistency over availability, right? If you have network partition, then Alice might not be accessible at a certain point in time. But we make sure it's always consistent. So the persistent entity, or in DED terms you aggregate root, is your boundary for strong consistency. Anything that's a very... Oh yeah, and also so what plays into that is that the commands, of course, are processed sequentially. Just like actor messages, they come into the mailbox and are processed sequentially, so there's never any doubt about the current state of Alice, or never anything sort of executed in parallel that has to be converted in some way or whatever. So within this, we have strong consistency. This is also important to remember, because sometimes people say, oh no, it's all about eventual consistency, and it drives me mad, and I don't have any security there, or any certainty that something actually happens, or what the state of Alice is. The state of Alice is the state of Alice in memory. You can create a state, and you can, if you're smart, you do this, so if you have some information from the query side that leads you to a certain action on Alice, if you're smart, you check the state before you actually do the action on the actual entity. The event store, well, you can configure it in different ways, right? And a sane configuration for Cassandra would be to use a quorum across a couple of nodes. That will always give you consistency on read, right? If you have a write and a read quorum, then sort of it will check that the majority of nodes, or the majority, the quorum is read, and you have a consistent view of this entity. They call it, well, data stacks or the people behind Cassandra, they call it tunable consistency, because you can tune the consistency in Cassandra. You can say, I don't care about this, I'm just going to, if the write succeeded for one node, it's fine with me, I don't care if it has been replicated to the other nodes. But what you probably want is a more sort of a more safe approach for this, and say, okay, it has to be kind of, say you have you replicate the data across 5 nodes, then you say, okay, I'm going to have a quorum of 3 nodes, and so the write will only succeed at the point where 3 nodes have confirmed that they and the same for the read. So at the read, we'll get to that point as well. So you don't have any transactions across different entities or anything in Cassandra, but we don't deal with Cassandra anyway, right? We just deal with our persistent entities. Now the read side can always be delayed. There's no consistency, or no strong consistency between the write side and the read side. As I said, if you write, it's going to be events that are issued, and then the read side is going to be updated. This is not as scary as it sounds, so this is what we have. If you use an interactive system in the web, you're going to use optimistic locking and stuff like that. They're not going to query a database table and then lock it until the user says, okay, I'm done looking at this, it's fine, do something else. You're just going to, you're going to give the user the data. At the point the user sees the data, it can already be outdated. Things can already have changed in the database. So any interaction the user does based on this information can already sort of meet a different state of the database. And the bigger the distributed system becomes, the less sense it makes to think of it as something that has a global, consistent state at a certain point in time. So this is, of course, this is a different way of thinking compared to the central relational database, the traditional Java EE model, but it does work for a great many use cases. Summary, blah, 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 blah. Okay, I'm not going to tell you again. Oh, wait, maybe this slide. So I said Lagom is pushing you towards event sourcing in CQRS. It's not handcuffing you to it, though. You can use other things. You can basically anything. You can use anything that you can use, or you can use Akka persistence. So purely, you can use anything that works in Play. You can use in Lagom as well. So you can use Slick to talk to relational databases. Once we have the Scala Lagom, or now you can use JDBC or whatever. We actually provide a Cassandra set to interact with Cassandra directly. So you can write into your own Cassandra tables, you can things like that. Of course, as always in reactive systems, beware of blocking APIs. If you use JDBC, you're going to introduce some blocking, you have to do some configuration around that. So, that was a lot of talk about event sourcing at CQRS. Any questions about this right now? Because I'm going to move on to other topics. And it's going to be a bit short on the other topics, don't worry. I'll just keep your questions until the end. We're going to use another 10 minutes or so to go through the rest. So reactive. This is the image from the Reactive manifesto, the 4 reactive tenets. We need our systems to be responsive. To achieve this, they have to be elastic and resilient. And to achieve this, again, it's best to make them message-driven asynchronous. If this doesn't look familiar to you, then you haven't been to reactivemanifesto.org. So once you get home after this meetup, go to their website, read the Reactive Manifesto. It's just one long page. I don't put it down here. It's pretty good. So asynchronous, message-driven. Everything in Lagom is basically asynchronous. Just like in Play, or the way it uses Netty to handle the HTTP requests, so it does not use a thread per request model. It's also turned into events, say, that are processed by the workers. So on the I/O level, it's all asynchronous. And also, an interesting part of microservices, of course, is also to leverage asynchronous communication between services. You do, for crucial parts of your system, you want to avoid a request-response dependency between services, right? Because that makes this, that introduces a great possibility for failure. If you have a service that aggregates data from 3 other services and and relies on them being there and responding in time, that would make this service unusable if one of the others fails. So you get a sort of an exponential curve of failure possibilities. So each service should have the crucial data that it needs to operate. And so it needs to be fed this data to other services in an asynchronous way. We do this, we support this in parts, so in a point-to-point way right now by using WebSockets. So maybe to explain this, and this is another interesting thing about Lagom. Again, about the abstractions. Lagom introduces service as a concept. It says, okay, this is a service definition, and you can use this, you can inject this, and then use it like classes, right? Or like an object. Yeah. And it has a typed interface too. So you define a service, again, with Java-ish, and so each service operation will return a service call. Right? The service has a couple of service calls, and that's all these service calls are asynchronous. You never get back to the result directly. You don't get an HTTP result or a play.mbc.api.result or a string or what have you. You always get a completion state, which is the Java equivalent, more or less, of a Scala future, right? So it's a future that doesn't use the non-blocking get method like the standard Java future. It has a comment-based interface. So you get a future. I'm just going to say future Scala call. You get a future of response, and also it's you have to type again. It's type parameterized your service call interface. You have an ID type, a request type, and a response type, which is nice because it gives you type safety. All async. A nice thing also though is that your type doesn't have to be a materialized. So there's a plain type. It can be a source, a reactive stream source. So as a result of the service call, you actually get this input, this stream of things that you can consume. And we use reactive streams, obviously, and underneath it uses WebSockets right now. So that's pretty nice. Is there other bubbles? Yeah. So it's not straight, it's a stream, materialized as a WebSocket. That's pretty nice, but it's point-to-point, right? You have to call the other service, you get the stream back. What we're going to build in the next version is also a message bus. So you can just put messages on the bus, or you can sort of publish the main events on the bus, and other services can subscribe to them and update themselves. That's going to be based on, it's going to use Kafka underneath it. But right now we don't have it yet. All the Lagom servers, I said that earlier, can be distributed in a cluster. It's really Akka cluster underneath, right? It's built on top of Akka cluster, so everything you can do with Akka cluster. You don't have a master, you don't have a single point of failure, you can dynamically add and remove nodes. You can do this with Lagom. You have all the Akka features like cluster sharding persistence. Of course, this is used by Lagom persistence. And Akka circuit breaker, you know that possibly if you, a common pattern if you rely on also to protect external services that you use. If you use other services, internal or external doesn't really matter, but external to your system. So you call another service and it times out, or you get some, timeout will be a very typical example. Now, if you have a lot of requests that go to the service, they might pile up and they might it might be difficult for the service to recover because it's overloaded with more and more requests as things time out and are repeatedly tried and they just pile up. So the circuit breaker pattern says, okay, if a service times out a couple of times, I'm just going to open the circuit, I'm not going to bother the service again, and then maybe after a while, I'm going to try again. If it fails, I'm just going to open the circuit again. The circuit breaker pattern, which is built into Akka and also available in Lagom, of course. The developer experience of Lagom. So, command line. let's use this. So this is a GitHub project, and I checked out this project. I did a git co. Oh, I have co as a nice for checkout. I did git checkout for this project, and then once you've done that, you start SBT. So this is a simple project. This is our Chirper example project that you can download as well. It has 4 basic services: the Chirp, Friend, Activity Stream, and the front-end service. But this could be, you could have 40 instead of 4 microservices. And then I say run all. Now it takes a couple of seconds, but the important bit being, I did not have to set up anything at all. I don't even have to use Docker. I don't have to install Docker, or I don't have to install Cassandra. Well, that's good. I have to install. I don't have to install anything for service lookup, like the DNS server, anything. So this is literally all you have to do. So once you have a project, say you have a project with 20 microservices and you onboard a new developer and you want him to get started. This is literally everything he or she has to do. Check out the project, and that's it. So this is one of the nice things about Lagom. If you're familiar with Play, you know that, then I should have used the product that I have. Okay, Scala is here. You know that in Play, it will recompile on changes, right? And it will, oh wait, this is running on, we can actually start this too. This Chirp application, there's actually something running there. And printed out some text. Pretty stupid example, but just the point is you don't want to. Typically, you're going to work with a couple of microservices, not just one microservice, because you're going to build a system, or you at least for parts of the system. So the parts of the system you're actively working on. But you want to deal with a couple of microservices at the same time, because you might want to move things around too. You might not be 100% clear what's going to happen where, and or you might have to do changes in a couple of services in parallel, right? And so one nice thing, of course, is that just like in plain Play, if you do any changes in the source code, you don't have to redeploy anything. You don't even have to run a build command or anything. It should output the change, or is it not? If it hasn't, then it's not the right product. So this is actually the Lagom Scala Chirp. I said hello Prague here. Oh, I haven't reloaded it. Oh, have I? Hello Prague. So there's the little change there. It's a bit at the bottom, you can see that. So, of course, this goes for other changes. Again, the idea being to have just helping you be productive, right? Just make it really easy to get started with this and to do your changes and just see them immediately. Cassandra server. Again, I didn't have to install Cassandra or anything. Lagom just starts an embedded Cassandra, actually even persisting the data to files. Or you can trigger this. You can also say start with a fresh one on each one. It also has an internal service lookup, right? So these the services can find each other. Oh, by the way, these port numbers are generated by Lagom based on it's basically a hash, I think, of the service name. So they're also they could be the same if you start it again, unless you rename the service. Yeah. So. Well, it's as simple as that. That's the development environment. Of course, you can load it all into the IDE and then work with that there. Don't have to worry about Cassandra. How to load it, I should do. So, run all the services at once. Of course, in production or whenever you push it to staging or wherever, they're going to be, each service is supposed to run on its own JVM. Right? But here it's just to make it faster for your development. It's just going to use one JVM with different class loads per service. It runs a Cassandra DB, it provides a service locator, it provides hot reloading. And now you've developed your services, and you want to move them to production or to staging or whatever. And this is where lightweight conductor comes in. This is an integration already built. So the idea is to have a sort of a push button simpleness to moving it somewhere else. You say, okay, I have my cluster, well in our case here a conductor cluster, or of course it could be something else, and you want to be able to basically from SBT say push it there. Of course we are the ones building conductor, it's our product, so this is the first integration we built. I know that Jonas von Nair already created a service lookup based on console, I think. You can use, instead of building conductor bundles, you could use Docker images to build your system. So basically, the way it works is that we provide an abstraction where you need to have some deployment format, and you need an abstraction for service lookup. This is the basic functionality that's needed from within the application. And this is provided by the development environment, the service lookup, and by conductor. But you could define other providers, or you could implement other providers to push it on other systems. So this really tackles the third of the three trade-offs that Martin Fowler mentioned, right? The operational complexity. We looked at distribution, we looked at eventual consistency a great deal, and the third one was operational complexity. And you need some kind of tuning to make it simple again. And conductor is one example for this. And because in the interest of time, although it's not only 12%, so I am actually going to talk about conductor a bit. Do we have some more time? 10 minutes or so? Yeah. So what makes operation simple again? Right? We say we have this operational complexity because we have these many services that we have to put somewhere. How can we make it simple again? Well, first of all, you need a simple deployment format. I think this is one of the reasons why Docker is so popular. It gives you Docker images. You can create an immutable image. You know exactly what's in there. You can throw it away, create a new one. It's not, and all the dependencies are in there. It's not like, oh, I have this one binary I put on the server, and I have to make sure that all the library dependencies are installed there, and then I do some configuring on the server. No, it's of course, we already had this with AMIs and baking immutable images for virtual machines and things like that, but with Docker it's become much more lightweight. We've become even more lightweight. You don't even have to use Docker. You can also, because for a JVM application, the JVM is sort of the only relevant dependency on your server side, or that has to be pre-installed. If you have a supported JVM, we pack all our dependencies anyway, right? If we deploy a jar somewhere, we just put all the dependencies, or we deploy all the dependencies with it. At least that's what we do in Conductor. So we can create something we call a bundle, which is basically a zip file with a runnable jar and all the dependencies on it and the configuration. And then it has a certain structure, of course, and then we create a hash code of all of this, so we can actually check the consistency of it and have a unique identifier as well. Okay, so we have this super simple deployment format, either a Docker image or a zip file with all the dependencies in it, with a unique identifier, immutable and clearly identifiable. Now we want to deploy it, and we certainly don't want to log on to to single nodes and say, I want to deploy this on this node and this node. We want a tool that takes care of this. In Conductor, we provide a REST interface, and you take the bundle and say, load this into the cluster, and Conductor will load it into the cluster. And then you say run it, and Conductor will run it. And you say, I want 3 instances of this, and you want 3 instances of this. You say, I want 10 instances of this, and you want 10 instances of this. With Lagom and Akka cluster, we actually make sure that the nodes find each other, and that the newly started instance will join the cluster automatically, things like that. You have to provide service lookup, of course. You want your orchestration tool or your application lifecycle management tool to take care of what's running where and to be able to stop something at on a certain node and put it somewhere else. So you want some location transparency there, but you also need to find, of course, other services. So it has to provide service lookup, and you want some support for resilience. You want to make sure that if something crashes somewhere, there's at least some basic support by the tooling that will possibly restart it somewhere else, or make sure that the number of instances configured is kept. In Lagom, every service you build with Lagom is ready to run a Conductor. With a single command, you can create a bundle. let's check. I think I started it earlier. In one of these. I started it up in there. Oh, the stopping takes it. Okay. Maybe not. So, one thing we provide with conductor 2 is, wait here. There's something called a sandbox. You develop a sandbox. And this, again, kind of uses Docker to simulate a cluster. In this case, I want to sort of pretend I have a cluster of 3 nodes where I want to deploy stuff on. It probably takes a minute or so. Okay. I can already see, I deployed one application already in the visualizer. It's still starting up. So it should be at some point, should be 3. ESLi is not important right now. This is just used for a log aggregation. So I started a conductor. No, it's not localhost. It's bigger. So you can see, I have three nodes in my cluster here, and I have 2 applications running. This ESLi, which is for Elasticsearch Lite. It has the same interface as Elasticsearch. It's a totally different beast, though. And a visualizer, which is the application we're actually looking on right now. Looking at right now. Now, from my project, the project we saw earlier, and from SPT, I can now create bundles and deploy them there. Well, as microservices go, the idea, of course, is to deploy them independently. So, actually, for demo purposes, the next version is going to have an install all command, but I don't have it yet. So, here, what was it? And I have to create a Cassandra. I want to deploy Cassandra as well. And I can also, there's a little configuration there to generate the proper Cassandra configuration. I just forget the symbol for this, so this is the name for it. And then I say conduct load Cassandra, and as a second argument I give this configuration. So services, right? So it's oh wait, no, I can create the bundles at the root level. So it's this project is has a root project and has at least four sub projects. Well, actually, each service has an API part and an implementation part. An API part and an implementation part. But in terms of services, there are 4 services that are interesting to us right now, and the implementation bits. Use the Lagom plugin, just like you use the Play plugin for Play applications in SPT, which does the hot reloading and some other nice stuff for Play. There's a Lagom plugin, so if I do bundle this, which will create the bundles for Conductor, it will actually sort of go to the sub-projects, and for each project that has the Lagom plugin, it will create the distribution, the bundle. So with one command, and again, this is 4 services now, it could be 40, it could be, I don't know how many. I'm not going to say 400 because it seems a lot to me. Probably need a lot of memory for that, but of course will still work in theory. So now you created, think of this as Docker images, now you created a Docker image for each of the services with one command. But now, actually to load this into Conductor, I actually have to go into each project. But, oh no, wait. So I say conduct. No, maybe it works with that. maybe while I do this, which takes 3 minutes or so, you want to, maybe somebody has a question? Ah, come on, you must have one.
So how do you do the excuse me, load balancing? So you mentioned that you have certain strategies. How to
Okay, we'll come to that. Another question. The load balancing. Okay, so there are different levels where you can do the load balancing. You could just, so each of the conductor nodes. So each of the conductor nodes is actually a proxy as well. So it will redirect the request to wherever the service is running, right? Or well, it will actually round robin around the number of instances. So here, right now, the visualizer, there's only one visualizer running. But I was a bookmark that I was not supposed to open. So this port, 9909, will actually point, I guess, to this instance here. Oh wait, this is, which happens to be the one where the visualizer is actually running. If I say 19, now the request now arrives at this instance here, where the visualizer is not running. So, but there's a little AJ proxy running on each of these nodes, which is controlled by Conductor. Conductor automatically writes the configuration for AJ proxy and will event-drivenly reload it. So it will know where the visualizer is running, it will redirect the request to it. If I would have 3 instances of visualizer running, it will round robin the request to it. So you have a location transparency there. And you have a load balancing in the sense of the round robin that it does. But in the end, none of these IPs or none of these nodes should be exposed to the outside. Because you want these to be able to crash and to be replaced with other nodes. So you still want to have a load balancer outside of the conductor cluster. Some people like to use AWS, so you would have ELB, an elastic load balancer, in front of your conductor cluster, which could just round robin all requests to any of the conductor nodes and would take care of any nodes of disappearing completely. An alternative, of course, would be you could expose, so you could, but I would have some load balancing infrastructure in front of it, technically, basically all you need would be here. You could use AJ proxy for that. You could use AJ proxy for SSL termination, which is also something we recommend. But then you would have to have an additional IP, let's say a public IP, that is exposed to the outside, and that's being handled by one of these nodes. And if one of these nodes does actually crash, you would have to assign this IP to one of the other nodes. So you would have to have additional tuning that sends heartbeats back and forth and checks if the host carrying the public IP is available, and then would take over the public IP in case it fails. But this is not handled by Conductor. We recommend, basically, as a simpler setup, we recommend to have an additional load balancer up front.
do you use Docker Swarm?
No, Docker Swarm would be an alternative, right? This is sort of the area where we're playing. There's Kubernetes, there's Docker Swarm, there's Marathon, and there's Conductor. So some things, so we can run on mesos like Marathon, we can run with Docker like Kubernetes. So we do, we sort of do what they do, but we do it slightly differently. I'm not very familiar with Docker Swarm. There might be points where it makes sense, maybe it makes sense to combine it. But my point of view is that you sort of, or a more normal, I think a more normal approach would be to pick one of those. You say, okay, I'm going to go with Kubernetes, or I'm going to go with Conductor, or with whatever other tools are out there. Yeah, interestingly, so if you're interested in this something, it can run. So Conductor runs, in this case, this is the way I run it, 3 instances in 3 Docker containers. It's not the way it's supposed to be run, right? It's supposed to be one Conductor really per virtual machine, so per on the OS level. And then you can combine it with Docker server and use Docker images for these bundles here, for your applications. So I use Docker images for the big ones, but that's just for developers. That's the developer sandbox. You want to use a read server or a virtual machine for the big ones, and then you use Docker for the small ones. It can be an EC2, it can be a real hardware, of course, or it can run on Mesos. I don't think the version is published yet, but we are working on a version, and we have it, so it's at a beta stage where it runs on Mesos. Mesos is a cluster manager that's often used and conducted with Spark, for example. If you have a lot of hardware and you want to manage this sort of as one computer, the data center as the computer, the old Borg approach, Mesos is a tool that provides this. Or actually there's a company called Mesosphere that provides support for Mesos and builds a product that's called DCOS, the Data Center Operating System. So that's a very powerful combination. You can use the data center operating system and Conductor on top of that as a tool for the interactive or akka playing on whatever applications, a lot of applications you build, and then use the same DCOS to run Cassandra, Kafka, Spark maybe, make use of your hardware. But, okay, I actually wanted to say all these things while I deploy the other stuff, right? Maybe another question? Or was the load balancing question answered?
Yes.
Okay. Any other questions?
Is Conductor, it's a paid product, right? It's not free.
It's a paid product, yeah. This is why we have this indirect, right? So we kind of want to get some attention onto Conductor. So with Lagom, we have this nice integration. So people see how nice a tool it is and how nicely you can just, integrate it with, also how nicely it fits into this whole service, microservice world. But of course, yeah, Lagom itself is completely open source. Maybe at some point we're going to have, I don't know if you know that, but we actually have commercial Akka features. So Akka is completely open source, but we have the Lightning Reactive platform that actually has commercial Akka features like monitoring, a split brain resolver, some configuration, sanity linter. So maybe at some point we're going to do the same with Lagom and say, okay, we have a cool security feature or some ops stuff that you need a commercial feature for. Actually, right now, if you want to see the circuit breakers or the circuit breaker visualization, is actually enlightened monitoring. So you actually need the commercial monitoring to see the state of the circuit breakers. I think. Maybe you can also look at the log files, okay, but if you want to see it in a nice dashboard and stuff, you need to use that. So, okay, and this was it. Now I have to run them too. Oh, damn. Can I run Cassandra? Yeah, I shouldn't be doing this. This is a bit tedious. I'm going to do the demo again when we have this installed whole thing. But now, it's basically this SVT plugin I'm using communicates with the REST service of Conductor and just tells it to run these services. So now I can start Cassandra, I can start the other ones. And then you can see the same thing I showed you in the development environment. You can see the Twitter-like Trip application running on Conductor. But the point really being here that you see there's not a great deal of tooling involved. You say bundle dist and SVT, you say conduct run, or you say conduct load, you say conduct run. That's it. And well, hopefully at one point that's also work with other tools. But then again, Conductor is not the worst tool to work with. Okay. I think that was, or let me just quickly go back to my slides, but I think that was about it. So it's all ready to run a Conductor. What you get with Conductor is basically what service lookup. The nice thing about Conductor is that it has this built-in. I said it's about reducing operational complexity, right? So you don't want I mentioned Kubernetes. In Kubernetes you have Kubernetes, which is itself a beast. You have a master and your minions. So you have it's a non-uniform deployment. It uses Zookeeper. No, it uses etcd or etcd for configuration, which is another distributed application you have to maintain. It uses SkyDNS usually for service lookup, which is another tool we have to run. Like, we run it on Kubernetes, but it's a lot of stuff. People love Kubernetes as a hosted platform, but they don't want to maintain it themselves. So Conductor is a simple deployment, and it has service lookup built in. It has it is a uniform deployment. There's no master or anything. It doesn't use Zookeeper or any configuration manager. It just uses internal Akka cluster stuff. It will check for, I can kill a node, and then we'll restart the bundles and other nodes. And if you just log to standard out, it will consolidate the logs and actually make them searchable and stuff like that. I talked about the bundles. I talked about the REST API. I just talked about this a second ago. It's really about simplicity. Simplicity and resilience are the two sort of main things about Conductor. Resilience is so important because if your system is down, it's shit. It doesn't matter if it's great and has great design, great functionality, you had great ideas. If it's not running, it's of no use to anyone. So resilience comes first and foremost. Make sure your system doesn't go down. Our security systems. Conductor, just like Lagom, build an Akka cluster. It's a node where there's no single point of failure, there's no master, it's dynamic, and with the split brain resolver, it can actually handle network partitions, so it can define strategies for handling network partitions. So if your cluster splits, you can say these nodes shut themselves down automatically because they're in the minority, for example. It's the default strategy there. So you never end up with a split brain, right? You could have a network partition where both sides don't know what's going on the other side, and then you could end up with two Alices, which we clearly want to avoid, because the whole idea of our persistent approach is to have consistency at that level. So the second Alice would shut itself down. And the resilience, I already showed the location transparency. It doesn't matter where a service is running, it can crash, the request can be forwarded to another node. It will handle bundle failure or node failure, and then blah, blah, blah. So this is the summary. I said I wanted to point out the things that are special about Lagom, right? It's a microservice framework, okay, there are many of them. I think Lagom is different in a couple of respects, not only because it's built in Scala, and we are going to provide a Scala API, hopefully in autumn. It has already been pushed back a bit. We're just short of people, or short of sort of money we can invest in this Lagom development. It's all open source after all. It's open source, you can contribute. I don't think the Scala API is the best part to contribute right now because it's a lot about API design, but there are already a lot of open issues and also simple ones that could be picked up by the community. So again, what makes Lagom special? It's about, it's based on Akka cluster, it's about sort of being able to scale and being resilient. This is built in from the start. It provides a guided approach to the whole event sourcing CQRS. So I tell people, even if you're not interested, maybe you're not that interested in the whole microservice thing, but you're interested in event sourcing and CQRS, I think this is one of the, well, I don't know that many, but it's certainly a very interesting CQRS framework. I was about to say it's one of the best CQRS frameworks out there, but if you're interested in event sourcing and CQRS, I think Lagom is a very good starting point. There's a very nice video by Patrick Norpal explaining his approach. He designed this and demoing it. So if you're interested in this, Lagom is a good, just a good playground. It's nice to play around with in this area. And of course, it's we provide a very nice development environment and a simple way of sort of without much additional tooling to push this into production. If you're interested in Lagom now, which I really hope you are, it's on GitHub. Oh well, there's the website. There's a getting started button. You can download the template. You can download the Turbo example you saw here, and even smaller Hello World one, the one where we looked at the persistent entity source code. It's all open source. It's all on GitHub. Of course, there's not only the source code. There's also GitHub issues. There's also a Gitter channel where the Lagom developers are usually online, so you can enter a direct conversation with the Lagom team. Or if you want to do it asynchronously rather than having a conversation, or you have a more complex question, there's also a mailing list, of course, for Lagom. Please, if there are play around with Lagom, We are always interested in feedback. If you think we already got very good feedback about things that people miss in Lagom, or we're going to change the whole service definition approach to remove this binary dependency. Right now we actually create a binary dependency on the service definition when you inject the other service. So we want to decouple that. We're probably going to build some kind of process manager implementation that you can use within your services, things like this. And this is all because of user feedback we already got. So if you have this kind of feedback, we're really happy to hear this. And as I said, it's going to be the actual Lagom developers you're going to be talking to both in the GitHub channel and on the mailing list, and they hear you. Then, if you have, this is a really, really thin book, it's maybe 40 pages, and it started off as a white paper, I think, so the idea was our CTO, Jonas Bonner, said, okay, there's a lot of bullshit being said about microservices, or people forget important things, and we want to be clear about this. We want to express our vision of microservices. And he started writing it down, and then somehow he got in touch with Hawaii, and they said, "Oh, cool! Let's make this a little booklet." And you can, if you go to some event, we often give it away. Actually, unfortunately, I don't have any here now because also I flew in. I can't really have to be at home, so. But you can also get a printed copy if you see us on some event, but you can definitely download the ebook for free, which is probably what you read more anyway, right? So you can download, I think it's a PDF or EPUB. And as I said, it's really short and it's a really good read. It also has great pointers to other papers about eventual consistency, about resilience and services. So you should definitely download this and read this. Yeah, and this is really it. Thank you for your time and attention. Thank you.
Can you show us conductor if there is any more information than the next picture?
Like show you conductor running or show you information about conductor?
Conductor running and what else is inside?
So the thing about conductor is it doesn't really have a UI, so there's not much to see. You can see here like info, which queries the REST API. You can see these are the bundles or services I deploy. And conductor will create 3 copies of each, just for resilience. So if one crashes, it has another one on another node. And these are the ones that are running. These would be, if there would be one here, that would be the starting state. This is part of the management of Akka cluster application that makes sure the first node is started exclusively, and then the other ones, the first node is provided to the other ones as a seed node, or to the next ones as a seed node. So it would it sequentializes your Akka cluster startup. So you know, because you have to provide seed nodes for Akka cluster, conductor of course needs to manage that. So that's what the starting state is for. And then we have this visualizer application which I deployed where you can see the things running.
Can I see ports on which this is running?
Not interactively. You can't really. At least I'm not sure. Let me. Wait, you could. I still have this. I have if I find this old curl command in my history. These are a lot of. I need to create something else. What's that? I would have to look up the command. So you can actually. I'm not sure about the sort of the little script there. Queries the REST API, right? But you can also query the REST API directly. I think this was the what happens here. Okay, now. So you can see here, you can see a couple of ports. Now I would have to There's a Python script that or there are a lot of ways to format the JSON nicely. And I have a Python script that does it. I can pipe it to that. I just don't remember.
And there's JQ, which is also doing this JSON box, you can vary.
JQ?
And it sounds like.
I don't think I have that. Yeah.
Everything.
JQ. No.
No. Yeah, really start properly.
So, but the short answer being yes, you can query it. So there are two ports that are really interesting there. There's the port that is exposed to the outside, and I said conductor, there's an HA proxy running on each of these nodes, right? So the port that you define in your service definition, actually it's in your build SPT. You say, okay, register this service under this name and this port, for example. Expose it at this port, the endpoint. You define the service endpoint. You say maybe it's port 9000. And that's going to be the port that HA proxy is going to listen to. And it's going to redirect it to. The port that your service is actually running on, the actual, so the JVM Java application, is given by conductor. It uses, you can configure the port range, but the default is some, I don't know, between 10,000 and 14,000 or so. I will use a random port for this, which allows you to have to deploy a new version, for example, of your service under the same endpoint. Right? So if you would, well, it's simplistic, it's almost stupid to explain because you all know this, but if I would start my application on port 9000 and expose this to the outside, and now I want to start a new version of my application, I cannot start it at port 9000, obviously, because the address is already in use. So I need this level of redirection. I expose a certain port to the outside, redirect it to a random given port on the inside, and then I can sort of deploy a new version, scale things up, scale things down, and have the same endpoint to the outside. So there is a...
the directory and then formats.
Oh, okay. I still use the curl, and then I say this one. Oh, it's something, it does something.
Yeah.
So I guess these are the random ports given by conductor, but the endpoint is going to be something that's 9004. Well, actually, this phase, I have to look for this a bit. But yeah.
You can use the same tool to filter out in JSON.
Okay.
I mean, not now. But
Yeah, okay. I'm going to look at this too. It looks very useful. Anything else? So there's a I would recommend just going to the conductor page, lightband conductor, and then you see there's this whole getting started thing, or you can get the developer sandbox, which is basically what I used. So you have to accept the terms that you're not going to use it in production, and then you get the instructions here how to install it. And this is all free, right? For development, this is all free. It's only if you want to use it in production where you have to get a license. Okay, I see this page now. But and all the conductor documentation is open source and on GitHub, and it's on conductorlightman.com. And this really all this is also the documentation our paying customers get. So there are no secrets. Everything you want to know about conductor is basically, or everything, yeah, is there. And as I said, it's even on GitHub. If you have a question or if you feel something is missing, you could actually create a GitHub issue and say this is not explained in the documentation how it does work. So that's conductor.lightman.com.
Can I ask, why did you start with Java API first
Oh, you're the first person to ask this, ever. Of course, everybody asks this, and there have been huge discussions about this at Lightman as well, but it's just, I think, it's not because we don't love Scala anymore. It's written in Scala, and it's a bit of a marketing stunt, so we wanted to get more attention from Java developers. The Scala developers love us anyway, so we wanted to get sort of more people on board. And also it's a resource thing. I would say we were discussing what the idea, the idea in agile iterative development is to create a minimum viable product and start with that. So we discussed how many languages does a minimum viable product we have to support. Is it still minimum? And we said we have Scala and Java. We said no, it's going to be one of them. And then was the question, what should we do first, Java or Scala? And we said, okay, maybe, as I said, to get more attention in the Java world, to not be seen as the Scala company only, because we are the Scala company, but we're also the Akka and Reactive, and hopefully the microservice company. So we want to be seen as that as well. So we thought that maybe it's good to be a bit disruptive there, not to do what everybody expects, or another Scala framework. Let's do Java first.
Was it successful? Because I guess you made also Scala people I wonder whether you made like also people
successful would be. So we got. I think we had a lot of good conversations with Java user groups and a lot of. I think we did get a lot of attention in the Java world. I think when it comes to press coverage and online coverage. In terms of really uptake by the developers, I think we would have expected even more. So we have some. There's a growing community. You will see this online. There are vivid discussions on the mailing list and on the GitHub channel. We actually have customers trying it out now. I don't think they're quite in production yet, but people that were in the process of sort of redesigning the system to a microservice approach anyway, are looking at Lagom now and really like it. It's still quite disruptive for Java developers. You still have to use SBT. As I said, we push you towards event sourcing. You don't, if you just want to use Lagom with your MySQL database, it doesn't really, we don't really help you with that. So I think for a lot of them, they sort of look at Lagom and they say, oh, well, actually I don't want to deal with this right now. I'm just going to use Spring Boot, or I'm just going to use something I'm more used to, and I don't want to deal with SBT now. I'm just going to, use Gradle or maybe. So we're going to probably, it's going to be, it's going to be a bit of education and marketing, and a bit of compromise too. We're going to probably provide some sort of basic support just to get this on the way.
Publish some roadmap with kind of predictable steps where you're going.
Good point.
Because this is what is actually missing for everyone, right? So,
this is actually, that's a good point.
Basically, when we compare with Spring Boot, they already have a much more predictable view on the future releases, and they're also going to react in Spring 5 probably. They're working on it right now. So actually, your choice to choose Java is to win the fight, right?
Yeah. So then, in terms of market share,
when you will be ready to go to the Spring meetup and explain what is Lagom?
Yeah, I don't know, next year maybe, so, or when it comes to, or we could go this now, but as you said, it's, they have this very different approach, right? They say, okay, we're Spring, we integrate stuff. And they were happy to have all this Netflix OSS stuff, and they said, oh yeah, we're just going to use Historics, or we're going to use Eureka, I'm just going to integrate it a bit.
Yeah, because they avoid Akka, right? The same way you avoid.
Yeah, they say we go with Reactive, right? They have Reactor for their sort of reactive parts. We do talk to them occasionally, and they're interested in Akka as well. It's a bit, I think it's also a bit difficult for them to sort of, to see how they would profit from Akka, or how they sort of have to integrate it in the whole Spring world.
You have created of Spring inside the type state on the board of management. So.
Oh, this is actually,
how it happened.
What Johnson is, when he was on the board, he's an investor.
He created Spring. He wrote the book Life Without EGP, or whatever was it.
Enterprise Java without EGP.
Yeah. So I personally, I saw
his influence in sort of the operational level, he's very, so he keeps out of the business, and he's actually not on the board anymore.
Okay.
He started his own new company with Russ White and Adrian Collier, what's it called, right? And they, Atomis, what they think? Yeah, I forgot the name, but if you look for, so they want to create some hosted services platform. I'm not sure what they're doing, but it's got something to do with microservices. They use some Scala, as far as I know. But just having him on board did not lead to us sort of cooperating with pivotal or Spring in an intense way. I think it's a difficult. I think there are points where we are complementary. So they could integrate Akka in some way, I guess, if they wanted to. Or you could use Spring.
It would be really nice to see the comparison. For example, code generation, right? You have certain things which are generated inside the framework. Like in Spring, you have a lot of stuff you implement interface, and a lot of hidden work is done by the framework.
Yeah.
So you probably have the similar things happening, right? And in the presentation on this level, we haven't seen it, unfortunately. Maybe it's just high level, but maybe next time, whenever you present it, it would be nice to see a little bit on this side. Like the code generation, what's happening underneath any magic, or any framework is doing that, right? Almost.
Yeah, well, actually, code generate. I think we don't generate quite as much maybe as others, but
there are some folders which you need to add, right, in order to make it work.
sorry, there are
Like
some.
you have some generated code as well, as I remember.
There isn't.
But typically you do entities and so on, which you can also generate.
Well, in the Java version, you could use the immutable interfaces that would generate code and stuff like that. I guess in the Scala version there wouldn't be much generated, but I see what you mean. Of course, there are things happening underneath, and you. So yeah, I encourage you to look at the source code to see how the incoming REST requests are mapped to commands and stuff like that. I don't think there's much generation really going on, but yeah, of course there are things happening. So you would like also to see sort of a comparison with the Spring stack.
Yeah, maybe it will be easier for other kind of Java people to enter.
That's good feedback. And
Or they will not be afraid so much of the two.
yeah,
Basically two things.
I think afraid is maybe a bit much, but it's, people are lazy too. If it's
And for example, the roadmap is one of the things which is really unclear. Like you mentioned Kafka, right? You have Kafka as a service. And where we can see about those plans. Is it on Twitter or is it also published somewhere?
I don't think we've published a Lagom roadmap, but yeah.
Exactly.
It's, we are but that's more or less the same for the other projects as well. We're always very shy about the future, especially about we need
basically, why should I take your framework, right? If I start now with Akka, I could say, okay, I take Akka cluster myself, and I'm trying to do exactly the same thing as you are doing, right?
We would be fine with it.
Yeah, I can fail, and then come back and say, okay, I take a ready product which is tested much better.
Yeah.
So those benefits basically, and the roadmap will maybe bring more attention.
Yeah.
Saying,
So it's
okay, you don't spend 1 year in development, you take it as now, and then in half a year you got Kafka for free, right?
Yeah.
Very good point, because you don't need to learn all the Reactive streams,
Yeah.
synchronize all the libraries, dependencies,
Yeah.
it's given, right? That's basically why Spring Boot is good. It gives you don't need to spend a lot of time fighting on dependencies, right?
Mm-hmm.
So you didn't mention this here as well, so that's nice to see this like.
Okay, roadmap. Oh, we'll take a look
Like
at that.
those
Lagom
reactive,
roadmap.
yeah. Basically, Lagom is the same, which includes all reactive streams, reactive Kafka, reactive Cassandra, and that's always a good point because if you do it as a single project and try to select all the versions,
That's part of the
it's very painful, right? So you need
Oh, very, but yeah.
yeah, you need to know, for example, Cassandra minimum version,
Yeah.
and so on.
Yes.
Okay, sorry.
No, that's fine. No, that's great. This is the kind of feedback we need to hear. And you also make some very positive points about Lagom does actually make a lot of things for future. And
It was very good to see that conductor saying that we don't need to bring always API and stuff because DevOps kind of it's possible to do, but it's complex.
DevOps, yeah, DevOps is great, but sometimes it may lead to teams that do more ops and less dev, and we want to free them a bit of that. I think make it easier to do. But more questions, remarks? Okay.
There's a lot of stickers over here too. Everybody wants some. Please take some.